Lavin from Particle, and today we're going to use a Particle Argon to make a skull shoot lasers out of its eye sockets. A foam skull, that is. Human and animal skulls are much tougher to find at the craft store and are not recommended for this project. This is a pretty straightforward circuit and should take you less than an hour from start to finish. If you haven't already set up your Argon, set it up now. Please go to setup.particle.io and follow the steps there before continuing with this video. For this project, you will need a breadboard, a push button, 2 laser diodes that work with 3-volt power, 3 resistors, 9 male-to-male wires, 4 male-to-female wires, a battery pack or other power supply, and a particle argon with a Wi-Fi antenna attached. The code will work on all particle devices, but the wiring will be a bit different if you use a board other than the argon. On the non-technical side, you're going to need a foam skull or any foam Halloween prop that you think would look cool with lasers shooting out of its eyes. Let's get building! First, we're going to put the argon on our breadboard. Find the pin on the side that is labeled GND. This is the ground pin. It's where the electrical level is at 0 volts. It's a reference point or common ground. Since voltage is the difference in energy between 2 points, the ground is the one point that all voltage in our circuit is measured against. Use a male-to-male wire to connect the ground pin to the negative side of your breadboard. Then connect the 3v3 pin to the positive side of your breadboard. Now you can start building your circuit. Now it's time to wire the laser diodes. We're using laser diodes for this project because they behave almost exactly like LEDs, but are way cooler. Make sure that your laser diodes accept 3.3 volt power, as many are rated for 5 volts. Most of the 3 volt lasers are still pretty dim, but they'll look cool on a dark, foggy Halloween night. In the lower section of your breadboard, away from your argon, insert your laser diode. My diode has red and black wires, though yours may have red and blue. Use a different wire to connect the black or blue wire to the ground wire. Then put a resistor next to the red wire. Connect a wire to the resistor and put the other end of the wire next to the D6 pin of your argon. Repeat this process with your second laser and the D5 pin. Now that we have our lasers wired up, it's time to make them actually do something. I like to use Particle's VS Code extension Workbench for programming. If you don't already have it, you can download it at particle.io/workbench. Once you have Workbench set up, create a new project. I named this one Laser Skull. Go into the source folder and open laserskull.ino. You will notice that there are 2 functions already created in the file. Void setup and void loop are mandatory functions that must exist in the code. Setup runs at the beginning of the code execution, and after that, loop runs constantly. At the top of the file, name your lasers and state where they are. Write const int left laser equals D6 for the left laser, and const int right laser equals D5 for the right. This way we can just refer to the lasers by name instead of by pin number. It saves ourselves confusion in the future, and my future self will appreciate that. After naming the lasers, we need to tell the board whether they are inputs or outputs. We'll do that in our setup function. Write pin mode left laser output, then declare the right laser the same way. This establishes the behavior of our pins. Next, we will go down into our loop function and actually turn the lasers off and on. To turn them on, write digital right, then in a parentheses, the name of the laser, comma, then the word high in all caps, then close the parentheses and finish with a semicolon. Then write the word delay, then open parentheses, 2000, that's the number, not the word, then close the parentheses, and a semicolon. And that'll delay it and keep the lights on for 2 seconds. Finally, we'll turn off the lights by digital writing once more. Digital write, then open parentheses, then the name of the laser, comma, low in all caps, close parentheses, and semicolon. Now that we have the code written, we need to verify that we've typed it correctly and that it's real code. Go to the top right of your screen and press the checkmark button to compile your code. If it compiles successfully, press the lightning bolt button to send the code to your Argon. This is called flashing the code. The status light on your device should cycle through a rainbow of colors before settling back to breathing cyan. Your laser should start blinking. If it doesn't, check your wiring again. Attach the button below the Argon in the center of your breadboard, so 2 pins are on one side of the breadboard and 2 pins are on the other side. Run a wire from one of your pins to the A5 pin of your Argon. Run a wire from the positive section of your breadboard to another pin on your button. Lastly, run a resistor from one pin of your button to the negative port in your breadboard. When you press the button, nothing will happen because we haven't programmed it yet. Let's change that. Now we're in Workbench again. At the top of the file, name your button and say what pin it's at. I named my button Red Button because I am not particularly creative. You could be more creative than I am. I believe in you. Also up here, create an int called button state. That's basically going to determine whether it's pressed or unpressed. Next, go to the setup function and declare the button to be an input by writing pin mode red button input. In the loop section, set button state equal to the status of red button. Then write an if statement that dictates different behavior for a pressed and unpressed button. If the input is high, that means the button has been pressed and we want our lights to blink. If the input is low, that means the button is not being pressed and we want the lights to stay off. Compile the code and flash it to your Argon. Now it should work. Test it out. Do your lasers blink on and off? All right! Now it's time to shove our lasers into the eye sockets of our skull. Mark the spot for your laser eyes and then repeatedly stab that spot with a sharp instrument. I used a screwdriver, but you could use a skewer, a pencil, or even a meat thermometer. I imagine it would also be fun to use a drill on the skull. Though I chose to avoid that because I thought it would be too effective in creating a hole. While stabbing the skull, it is helpful to think of minor annoyances in your life. Channel the frustration you feel when stuck behind slow walkers or when your dog won't stop barking when you're trying to record a video, so then you have to hold her. Slip the laser diodes through the holes and make sure they are secure. Make sure all your wires are still connected to the breadboard and try pressing the button. Congratulations! You now have a skull that shoots lasers out of its eyes! If you have any questions about this, or want to show off your own builds, go to community.particle.io and make a post. Happy hacking!